All right, you should be ready for the next step of working with rational expressions. You've simplified them, so now let's step up, and for right now, all we're going to look at is the multiplying. Okay, we'll do a separate video for dividing. Multiplying is very similar to simplifying. The only thing is you're going to have two fractions, possibly three if you get into the larger ones, but for the most part, we're using two. You still have your rule of always factor first, and the other rule still stands as well. You're looking for matching factors, one in the denominator and one in the numerator. And remember, when they reduce, you get 1, not 0. So let's get started. We've got a couple of them here that are dealing with monomials. So there's no factoring involved. You're just basically looking to see who's got common factors. So I'm seeing there's a b in the denominator that matches with this b over here in the numerator. You could have gone with this b squared, but it's just whatever you see. This a, it reduces with one of these down here. Well, I've got 3, so let's just take that down to 2. Now look at your, I think that takes care of letters. We can look at the coefficients. I know 2 goes into 2, and it also goes into 4 2 times. Now your 3 and your 15, there's something common there. 3 goes into 3 once, 3 goes into 15 5 times. And I agree, that is a hot mess. But I think we have got it all the way reduced. May just want to go by and see what's remaining. I have a 2 here, a 5, and a b squared. This gives me a squared is all that's down here, and this whole thing went out to 1. Okay? So if you put it all together, and remember you're multiplying now, that's 2 times 5 is 10. Put it with your b squared, and in the bottom, all you have is a squared. And that's your final answer. All right, let's do the same thing over here. I see 2 g's. Can you cancel them? I hope you said no, because these are on the same level. You cannot cancel if they're on the same level. You have to have one up top, one in the bottom. So there's not another h. Look at your numbers. 3 doesn't match with any factors. 2 and 5 are prime. Do you see that nothing reduces here? It's a little odd, but I don't want you to think that everything always has something to reduce. This one, you're just stuck with everything. So 2 times 5 is 10. And whenever you put the stuff in the bottoms together, you've got the 3, you have g squared, and h. Nothing reduced. Okay. Sometimes it's just good to look at the ones that are different. Okay, we're going to upgrade, and now we've got binomials. So remember with binomials, you always want to start by looking for something common. And another thing that should clue you in to look for something common is you see all of your exponents are 1. So that's the only way we can pull this thing apart is with common factors. So is there anything common with m minus 1? No. So there's no shared variables, and your coefficient is 1, so nothing you can do. Can you take anything out of this denominator? Yeah. Take 2 out. If you divide every term by 2, 4 divided by 2 gives you 2. All right. There's my times. So let's go up here. Pull out a common factor. 3 goes into both. So 3 divided by 3 is 1. 6 divided by 3 is 2. All right, look at the bottom. Is there a common factor? Well, you kind of are looking pretty hard at this 4, but you have a 1 in the back. So that kills that off. You're stuck. You can't pull out anything common here. It's not a variable that's common. It's not a number that's common. So now it's time for the fun stuff. Find your match. I have m plus 2. Remember, those are glued together. You have to do the whole thing or none of it. But the whole thing reduced, so we're good. Hey, check out this. I have an m minus 1 and I have a 4m minus 1. Can you reduce that? Because, hey, if you cover up, the 4, it looks pretty good. But can you just ditch the 4? No, you can't. So even though these two look really close, you can't do it. And you can't do anything with this 3 and this 2. So you're left with all that. So clean it up. We normally put monomials out front and put the binomials in parentheses. So even though he's not in parentheses, when you bring him down here, wrap him up. Same thing here. You've got the 2 out front and this binomial here, wrap him up. Because you're saying that monomial times the entire binomial. Remember, that's one whole entity, and you've got to package the deal. All right, upgrade. A little bit tougher. Let's see what's going on. Okay, my pen got a little big. All right, this one, got a 2 out front. Can you take out a 2? No, we have a 5. We're stuck with a 2. That means since it's a trinomial and there's a coefficient out there, this is the hard kind. Okay, so here we go. You need 2x and x to get your 2x squared. Now look in the back. I need 2 numbers that multiply to 12, but when I put them in my binomials, my middle terms have to subtract 5. So let's think. What is going to do that? Let's see, 3 and 4 work well, right? But we got to build up pretty big, so if I put the 4 with the 2, that right there gives me 8x, right? And the 3 would be here, that gives me 3x. They subtract 5. That'll work. Now work on your signs. Signs are different. Big pair's negative. Well, the big pair was 8x. 4x helped to make him. So he gets that sign. The other sign goes there. Right? Look in the denominator. You can't do anything with 6x. It's a monomial. Now this is interesting. Wow. You see it just looks like negatives exploded. Take a negative out. Solve that problem. Can you take anything else out? We can do a 3. So now just remember, all the way through, you're going to change the signs because you're taking this negative out. So if you take a negative 3 out of negative 3x, it's just x. Now negative 12 divided by negative 3 is positive 4. So you should see that the signs all changed. Now when you look in the bottom, it's a binomial, but there's nothing common. You can do square roots though, so this is difference of 2 squares. Square root of 16 was 4, and we need opposite signs. All right, you've got it completely pulled apart. Let's find some matches. X plus 4 in the top, x plus 4 in the bottom. Remember, it's the whole thing. X minus 4 over here, and there's an x minus 4 up there. That is perfectly okay. You can do them in separate fractions as long as one's in the top and one's in the bottom. It's all good. All right, anything else? You see this 3 outside, he's a monomial. With this 6 down here that's a monomial, you can reduce those. 3 goes into 3 one time, so don't forget this negative now. So you might want to just put the negative on the 1. And 3 goes into 6 2 times. I think that's it, guys. So if you clean it up, in the top you have negative 1. Now, there's several different ways to write it. Most of the time they just put the negative out front, and then you have the 2x plus 3. If you put that in parentheses, that's fine. In the bottom, you have the 2, you have the x, so just 2x. There you go. Let's see here. I do believe we've got one more of these. If you will factor, let's do this a little bit more quickly. It's a traditional trinomial. Multiply to 6, add to 5. That's 2 and 3. Signs have to be the same, both positive. You can't do anything with x plus 3. That's just a prime little binomial. All right, and these are just traditional, easy trinomials. So we need x's in front. What 2 numbers multiply to 3 and subtract to 2? Well, that would be 3 and 1. Signs are different. Big one's negative. All right, what 2 numbers multiply to 2 and add to 3? Well, 2 and 1. Signs are the same, both positive. Okay, fun time. Got to find your matches. Oh, let's see here. We've got an x plus 1 in the top, x plus 1 right there. Oh, look, x minus 3's. And look out, there's an x plus 2. This entire fraction went out. Isn't that cool? Only thing that you have left is x plus 3 in the top. So you don't have to put this. There's nothing mathematically wrong with it, but you're never going to see it typed that way on a standardized test or in a textbook or something, anything like that. So they're just going to take the 1 out of the bottom. It's just x plus 3. Okay, good deal.